as a record. Okay, so for those who are not around, last meeting, we started our discussion about the introduction for inorganic chemistry. So before I'm going to start really with the different concepts of the pharmaceutical inorganic chemistry, let's just have a short, I cannot call this short because it will take a lot of meetings for me to finish this. But anyway, this one is a sort of review for you in your general chemistry. So we defined chemistry last time. That's the study of matter. And when you say matter, it's anything that occupies space and has mass. So when you say mass, it's the total amount of matter present in a substance or a material. However, when you say weight, there is the influence of gravity. Okay, that's the difference between mass and weight. For the measures of, for the units of measurement, we use the international standard unit. We call that SI unit, and you have to take note of that. That just like when we say length, we use meter as our international standard ng unit natin. For mass, it's kilogram. For time, it's seconds. But for temperature, that should be Kelvin, since Kelvin has the absolute zero. And then I have given you examples of temperature conversion last time. If you have questions, you may ask me now. Baka hindi nyo lang siya, na-miss nyo lang siya last time, pero meron pa pala kayong part here na you are confused or hindi nyo siya naintindihan. You can ask questions, ha? You can raise your hand. May raise hand naman dito sa application sa Zoom, and unmute your microphone if ever you want to clarify something or if you want to recite. But if not, if you're not able to turn on your microphone, then you can send your queries sa chat box. Okay? Yes, Miss Tamadalan. You want to ask something?
Ano po, ma'am? Pwede po ilagay sa Schoology yung PowerPoint niyo po.
Yeah, after our class, I'll be posting this also para hindi kayo mahirapan anong tawag dyan, nag-take note kayo dyan para hindi kayo mahirapan. Kasi baka mabilis tayo, no? Tapos nag-next na ako, hindi pa pala kayo tapos. I'll be giving you a copy of this. So if you're going to take note, I think you may take note with the things that are not really found in my PowerPoint presentation, yung mga examples, especially for computations. Okay? Sige, let's have the classification of matter. So last time again, we defined this. It's anything that occupies space and has mass. Now, matter class are classified into two. We have the pure substance and our mixture. Again, we have the pure substance and our mixture here. Now, dito muna tayo mag-concentrate sa pure substance natin. Our pure substances are further classified into two. We have the elements and the compound. So last time I defined this also. When you say element, it's the simplest form of matter. Why? Because element is made up of one type or one kind of atom only. Again, that is our simplest matter. Kasi isang type lang yon ng atom. In the illustration, you can see it's made up of atom, one type of atom only. So yung illustration dyan, blue lang talaga. Now class, if we are going to combine the elements, two or more elements combined chemically with each other, that's the time we call it a compound. Okay? Compound na siya kapag na siya, combined elements, two or more. So itong mga elements natin, lahat ng makikita niyo sa periodic table of elements, syempre, ayan yung kasali dyan. Pero pag compound, again, element plus element. Hindi siya dalawa lang ha, pwedeng two or more. So we have the following examples. Sodium chloride, our table salt is a compound. So sodium and chloride are chemically combined with each other. And then we have H2O, our water. It is made up of two atoms of hydrogen. Let's call it molecules na lang. Two molecules of hydrogen and one oxygen. Okay? And then we also have H2O2, our hydrogen peroxide. In the market, we commonly call it agua oxigenada, H2O2. So use this one as an antiseptic. When you say antiseptic, it's any substance that can kill or inhibit or prevent the growth of bacteria or other microorganism. So again, these are the examples of our compound. Now, how about our mixtures? Our mixtures are combination of two or more pure substances. Therefore, ang mixture galing din dito. Okay? What does it mean? We can combine an element plus a compound, or we can combine compound plus another compound. The number though is not limited. You can have a lot of element in a mixture and a lot of compounds in a mixture. Okay? So ito sila, the combination of the pure substances in the mixture happen physically only. So what does it mean? There is no chemical reaction. Again, there is no chemical reaction here. They are just combined together physically. Anyway, sige. Next, let's classify our mixtures. We have here homogeneous and heterogeneous. How are they different from each other? Let's differentiate them. Ano nyo malalaman na homogeneous and ano yung heterogeneous sa pagkakaalam ninyo? Yes, Arte.
Yung homogeneous po ma'am is one phase lang po yung homogeneous habang yung hetero po is hindi po.
Okay, very good. When you say homogeneous, the mixture exists in one phase only. So they have uniform appearance. However, that is not true for our heterogeneous mixture kasi two or more phases may exist for heterogeneous mixture. Okay? So that's how we differentiate our different types of mixtures. So ito, nasabi ko na kanina ha, elements are our simplest form of matter. They are made up of one kind of matter only or atom. Ang compound, two or more elements combined or united chemically in definite proportion. Okay, pag sinabing definite proportion, we have certain ratio for each element combining to form a compound. So just like our water, this is my example a while ago. When you say water, it is always 2:1. So there is definite proportion. We have 2 hydrogen combining with 1 oxygen. Hindi pwedeng mag-iba kasi 2:1 talaga pag sinabing water. Okay? Kasi pag nag-iba ang ratio or ang proportion natin dito sa mga atoms na to, hindi na yan siya water. So kagaya nito, naging 2:2 ang proportion niya, 2 atoms of hydrogen and then 2 atoms of oxygen. Hindi na siya again water, hydrogen peroxide na siya. Okay? So again, compounds are made up of 2 or more elements united chemically in definite proportion. Okay? And then, ang mixture natin, again, composed of two or more substances that are not chemically combined. So what is the example of a mixture? The most common thing that we do for mixture, for example, pinaghahalo natin si sodium chloride and si water, forming our salt solution. This is an example of a mixture class. As you can see, we have one compound here and combined siya with another compound. So what happened when we place our table salt in water? There is dissolution. Matutunaw si sodium chloride sa water. Pero take note that there is no chemical reaction there. Okay? Therefore, ang salt solution class, walang chemical reaction na nangyari. They are combined physically with each other. That is why we only call the salt solution as a mixture. I hope that is clear. What other mixture do you know? How about if we combine sugar and water? Yes, Andrea. Atasha. Yeah, Andrea.
Sand and water po.
Okay, the sand and water. I'll get back with sugar and water later. Sand and water. So again, there is no chemical reaction involved here. However, the sand and the water are mixed together. So that is also true for the sugar and water. We call this our sugar solution. Did I give blood as an example last time? Yeah. Okay. So take note, our blood is also an example of a mixture. So anong meron sa blood natin? We have the, yes, Ernestine?
Air po, ma'am.
Yeah, the air. The air is also an example of a mixture. So kung sa blood, we have the red blood cells, white blood cells, our platelets, the plasma, the water, and all the other ions in our blood. So they are just combined but not chemically. That is also true for the recent example. We have the air. The air also is a mixture. So we have a lot of gases found in our air. Aside from the oxygen, we have also carbon dioxide, nitrogen, argon, and even helium, or what else? Ano hindi ko nasabi. Anyway, those are the gases that we can find in our air. And then again, they are not chemically combined with each other. They just exist there in the air. Walang chemical reaction na nangyayari. Later, I'll be teaching you also how do you know na merong chemical reaction. Para alam nyo kung meron ba or wala. Okay? So, dito sa mixtures natin, class, they are classified either homogeneous or heterogeneous. Again, this is under our mixture ha. Pag sinabing homogeneous, one phase. Pag heterogeneous, more than one phase. So for example, our air. Air is an example of a homogeneous mixture. Okay? Bakit? Kasi one phase lang yung ating air. Maraming gas dyan. Pero gases lang talaga silang lahat. So actually, we cannot see our air no kasi gas nga silang lahat. Our salt solution is also a homogeneous mixture. Once the sodium chloride particles are already dissolved in water, we can only see one phase. Okay? They all become liquid. Kasi nga natunaw na yung ating salt. Even our sugar solution. However, when you say heterogeneous mixture, we have more than one phase. Okay? So for example, we have halo-halo. That's the best example of a heterogeneous mixture. Iba-iba yung phase natin. Hindi uniform ang appearance. We have solid substances there, atong saging, atong sago. And we have liquid also, the water, and even the milk na nilagay. And yun lang, kasi hindi natin makikita ang gas. Okay? Cereal in milk. Cereal in milk, yeah, that is also a heterogeneous mixture since you have there the cereal, the solid one, and the milk as the liquid one. Okay? The pizza, yeah, it can be heterogeneous mixture. So, pagkaon dyan itong istoryahan ni Hino, namahaw mo. Namahaw mo or wala ta namahaw ani mo ng pagkaon ng atong istoryahan. Kaya kayo ni example ba kay cereal in milk, pizza, orange juice with pulp, bihonan. Gutmuntaan siya sa buntag. How about drugs? Sa drugs natin, example of homogeneous mixture sa drugs natin, syempre yung mga solution natin. Mga solution, yung mga IV fluid replacement natin, I believe lahat tayo naka-experience, ma-admit sa hospital or may family member tayo na confined sa hospital. So we also, even once in our life, the fluid replacement therapy. Though the misconception there is we all call that dextrose, pero hindi talaga yon lahat dextrose ha. Pili lang ang dextrose doon. Minsan ang binibigay nila is the PNSS. We call that plain normal saline solution. So pag yan ang binigay nila, malalaman natin yan kasi yung label is color green. Syempre that's a salt solution. Tubig lang yun, tapos nilagyan ng 0.9% NaCl. Ayan yung tinuturok nila sa inyo kapag na-confine kayo sa hospital. So that's an example again of a homogeneous solution. It's one phase only kasi nga natunaw na yung asin. Yung nilalagay nila sa vein natin. And then ang heterogeneous naman, example sa drugs natin, yung mga antibiotic suspension. So if you have experience na taking that kind of medicine, in the pharmacy actually it is dispensed as a powder na drug. And then i-reconstitute siya, the process is called reconstitution. Kapag kalalagyan na siya ng water, reconstitution ang tawag dyan. And magiging suspension na siya. Heterogeneous mixture yun, class, kasi the powdered drug are not really dissolved in water. Instead, they are just suspended in water. So if you're going to look at it, you will see the liquid phase and the solid phase for our antibiotic suspension. Hindi pang gutom na. Okay, I hope that is clear for our homogeneous and heterogeneous. However, our mixtures class can also be classified according to the size of the particle. So yung mga sinasabi kong solution kanina, under yun siya sa homogeneous. Okay? They have uniform appearance. And when you say solution, we always have the solute and the solvent. Again, ang solution natin, lahat ng solutions natin are homogeneous mixture. They have uniform appearance, but take note that we have two components for our solution, the solute and the solvent. How do we differentiate the two? Any idea? Ano itong solute and ano itong solvent na nasa solution natin? Wala. Si solute yung, yes, Gazelle?
Kumbaga po, ma'am, ang si solute po, siya po yung taga-tunaw and si solvent, siya po yung natutunaw.
Okay. Sige, baliktad. Baliktad siya. Si solute yung tinutunaw.
Baliktad po, ma'am.
Si solute yung tinutunaw, si solvent yung the one that dissolves. So for example, the salt and the water, solute, ang salt, siya magiging solute class. Siya yung present in smaller amount, and at the same time, the one that is being dissolved. And then si solvent is yung water. So si water is the one used to dissolve the solute. Okay? Those are the two, please take note, those are the two components of our solution. Okay? Sige, minsan nagkakabaliktad lang. Pero I hope ma-remember niyo siya. Solute ang tinutunaw, solvent yung nagtutunaw. Okay? Suspension. Nasabi ko to kanina. The suspension and the colloids class are under heterogeneous. Ito homogeneous. And these two are heterogeneous. So nasabi ko sa inyo kanina ang suspension. Since this is based on the size of the particles, among the three, this one has the largest particle size. That we can see the particles even just with our naked eyes. Tingnan lang natin, makikita na natin kaagad yung mga particles kasi malalaki sila. Kagaya ng suspension, yung antibiotic suspension na sabi ko kanina. If you look at it closely, kapag tingnan mo talaga yung before mo siya inumin, makikita mo doon na merong mga particles, solid particles na nakasuspend doon sa ating water. Okay? Largest particle size yan sila. Siyempre, halo-halo is included there sa suspension. Okay? And then we have the colloids. The colloids are also heterogeneous. Please wait for a minute kay Maraglobat ang akong laptop. Ayan. Sige, sorry for the interruption. Saan na nga ako? Sige, let's talk about the colloids. The colloids are also heterogeneous. But what is the difference between a suspension and a colloid? The colloid class has a smaller particle size. Smaller ang particle size ng ating colloids. But they are small enough to just be suspended in the solvent or the medium. Hindi siya natutunaw, pero nakasuspend pa rin siya sa medium natin, example water, pero most of the time we don't see the particles with our naked eyes. Okay? So what are the examples of our colloids? The mayonnaise class, the mayonnaise is a colloid. Hindi yan siya solution, hindi din siya suspension. Okay? Hindi siya solution kasi hindi uniform yung phase niyan. Merong solid, merong liquid. And most of the time, it's intermediate between the two. And then, hindi din siya suspension kasi we cannot see the particles with our naked eyes. So, colloid ang mayonnaise, and even ang ketchup. Yes, Rowena.
Fog and clouds po, ma'am.
Clouds, example. Yeah. Okay. Sige, that is also correct. And then meron ditong nag-send toothpaste. Yeah, the toothpaste is also a colloid. Okay? And even the milk na tinutunaw natin, nagtimpla ka ng gatas, that is actually a colloid, not a solution and neither a suspension. How do we see, sabi? Balik na punta sa atong pagkaon, butter, wasabi. Balik lang kita pero may sa pagkaon. Gutom dyan sila ba? Mustard. Okay. Sige. Anyway. Um, how do you know that margarine? How do you see the particles of colloids natin? Minsan, pwede natin siyang gamitan ng light. Okay, for example, gatas. Kinsay nakatry din na-curious lang. Kaya murag dili siya usually na ginahimo na to. Like, flashlightan na to ang gatas na atong gitimpla. Lata ka try? Lata ka try, no? Yes, Artea. Katry ka? Sana all. Na-curious. Pag na-curious ka, flashlightan mo imuhang gatas, you can actually see the particles of the milk being suspended in water only. Hindi siya natutunaw. Nasa water lang siya. Pero you cannot see it with your naked eye, so you have to have the help of the flashlight. That's how you see the particles of the colloids. So again, ang kaibahan nila ni suspension, si suspension, makikita talaga natin klase yung particles. We can really differentiate the solid and the liquid na phase. However, sa colloids, they might appear in parang uniform yung appearance nila, pero sa totoo, hindi. Yung example, kung may solid siya na particles, nandun siya, nakasuspend, hindi siya natunaw. Pero it's small, it's small and we cannot see it with our naked eyes. Okay? I hope that is clear. Sige, so ang properties of our colloid. Yung sinabi ko kanina na paglagyan natin ng flashlight, makikita natin ng particles, that's the so-called Tyndall effect. So pag sinabing Tyndall effect, it's the ability to scatter light. That's the meaning of Tyndall effect. Ability to scatter light. So pag mag-flashlight ka, example sa gatas, since the particles are suspended, andun sila, pero pag makapass through yung light glass, pero masascatter siya kasi mababangga siya sa mga particles being suspended. How about the Brownian movement? I believe this is always mentioned in chemistry subjects. Brownian movement. Brownian movement. Wala, past is past ang motto na to. Basta, humana siya sa una, no? Balikan na to. Brownian movement class is the, zigzag. We always call it zigzag motion of particles. So again, sa ating colloids class, since the particles are not really dissolved, they are suspended there, the particles are actually constantly moving in an organized pattern. So there is no really pattern, though we call that zigzag, pero unorganized yun. May mga particles na pupunta sa left, sa right, but as long as it's in constant motion, we call that Brownian movement. That's one property of colloids. So that's how we know na colloid pala itong mixture na ito. Kapag nag-exhibit sila ng Tyndall effect and Brownian movement. Hindi natin ito ma-observe with our solution and our suspension. Okay? Yung sa solution natin, hindi masascatter ang light kasi dissolved lahat ang particles. Walang magpo-cause ng scattering of the light. And walang movement of the particles kasi nga na-dissolve ang particles. So sa colloids lang ito. Now, let's move on to the processes of separating our mixtures. Class, please take note that mixtures can be separated physically. So since they are combined physically, there is no chemical reaction, we can also separate them. Physical pa rin. Physical processes. Now, how about the compounds? The compounds can also be separated. The elements in the compound can also be separated, but we also need chemical reaction para ma-separate sila. Okay? I hope that is clear. Now, how do we separate mixtures? First, we have the so-called decantation. What do we do with decantation? We let the particles settle at the bottom, and then we throw or we decant the supernatant liquid above. When you say supernatant liquid, let me draw this para masabtan ninyo. So if we have example this one, and this is the water here, we let the particles settle at the bottom, and then we throw this part. This is called the supernatant liquid. In short, kay pagkaon man pirmi atong ginaistoryahan din hino sayo sa buntag, pag naglungag ka, you're actually doing decantation. Di ba? Pag naglungag ka, you wash the rice, you let the rice settle at the bottom sa inyong kaldero, and what are you going to do with the liquid na gipanghugas ninyo? Ginayabon ninyo, di ba? Okay, that is the so-called decantation. So the next time, pagpalungagon mo sa inyong mama, yung mga siya nag-unsak ka, I am decanting mother the supernatant liquid. Tingali mong mama nunsak ka. Nunsak ka, That's the decantation process. Ha? Anong mag-irok John? Mag-squelag pharmacy. Kuya, na kayo ang istorya. That's decantation process class. Naglungag lang di ay. Nagkilis. Kung sa Bisaya pa, di ba, nagkilis ka sa, sa bugas. Sa English, we call that decantation after throwing the supernatant liquid. And then we have the distillation process. I'm not sure if you are familiar with the distillation process though, pero murag maglisod ko growing ana. Example, you have here the Erlenmeyer flask. This is connected with connector to wait lang, pwede ko pala mag-drawing. Here in the condenser, and then meron tayong like a receiver, another Erlenmeyer flask here. And then this is connected here to a Bunsen burner. So may flame ito dito. And then we have here two. Merong hose dyan. Meron din dito. This is the water inlet and this is the water outlet. Okay? Syempre nakaano yan ha, may mga clamps yan dyan connected to the iron stand. But nevertheless, parang ganito lang kaya I'm not good in drawing, no? Parang ganito yung setup ng distillation process. Again, we are separating mixture here and it involves two processes, evaporation and condensation. What do you mean by evaporation? What happened pag nag-evaporation process tayo? Yes, Arteya.
Evaporation po, ma'am, is yung liquid po nagiging gas po, ma'am.
Okay, very good. Evaporation is the process of turning liquid into gas. Okay, that's evaporation. How about condensation? Yes, Jana.
Where water vapor becomes a liquid po, ma'am.
Okay, so the condensation is kabaliktaran ni evaporation. We turn gas into liquid. So anong example class sa ginagawa na sa distillation? Example, pinaghalo natin si alcohol. Ay, what happened to my pen? This is alcohol. Alcohol and water. Okay. Again, pinaghalo natin si alcohol and si water. Now, we want to separate the two. Yes, we can do that kasi mixture lang yon. Walang chemical reaction si alcohol and si water. So, ang gagawin natin, ilagay natin dito sa flask yung mixture na may alcohol and water. I-subject natin sa heating. And then, we wait until one of them evaporate. So, syempre, ang pinakaunang mag-evaporate dyan, yung pinakaunang magbo-boil. And that is the alcohol. You know that, no? Na madaling mag-evaporate ang alcohol. So magiging gas si alcohol class. Pupunta yung gas dito. Ang tawag natin dito sa aparatus na ito ay condenser. Okay? Condenser yan siya. So sa condenser, malamig yung environment dyan kasi may water na constantly moving. So si gas class na alcohol, dadaan siya dyan. And then, from the process of evaporation here, magkakaroon ng condensation dito. So si alcohol na gas is turn back into liquid. Pag naging liquid siya, i-receive siya dito sa receiving flask natin. So ngayon, na-separate na natin yung mixture kasi naiwan si water dito and nakuha natin dito si alcohol. That's the process called distillation. Okay? So ano pa yung ibang examples nung nag-undergo ng distillation? Our crude oil. Yung langis natin, yung oil, yung kinukuha nila, marami nito sa Middle East, no? Kinukuha nila sa ilalim ng lupa, na oil talaga. Actually, nag-undergo yan ng distillation process. Okay, again, nag-undergo yan ng distillation process. Anong ginagawa nila? Yung crude oil class, wait lang ha. Ay, may chat pala. Yeah, oil refining. Perfume manufacturing also involves distillation process. Wait lang ha. Yung crude oil class, nilalagay nila yan dito. Pero fractional distillation yan. Isa-isa nilang kinukuha. Lalagay ang crude oil dyan. And yung pinakaunang mag-evaporate, syempre yun yung makukuha dito sa receiving flask. So, ganito yung process. Ang una nilang makukuha is the gasoline. From the crude oil ha, si gasoline ang unang magiging gas. Therefore, siya yung unang makukuha. Actually, marami pa yan. Pero let's just give examples na familiar kayo. And then you have the kerosene. After the gasoline, ang next na mag-evaporate si kerosene. So makukuha na naman siya dito sa receiving flask. And then marami pa yan in between, but we also have the diesel. So ang diesel makukuha din yan. Pero medyo huli na ang diesel class. Kaya kapag meron kayong sasakyan, tapos gasolina ang nilalagay, pwede nang hindi pa initin and mabilis siya tumakbo yung sasakyan na nakagasolina kasi madaling sunugin yung gasolina, madali siyang mag-evaporate. Okay? Whereas kung diesel ang sasakyan nyo, 'di ba? I don't know if you have observed that, pinapainit mo na siya before maglarga. Okay? Kasi ang diesel class matagal sunugin. So matagal siya mag-evaporate. And yung maiiwan dito class kapag ka nag-distillation process tayo with the crude oil is the so-called asphalt. Okay? Aspalto. In short, saan natin nilalagay ang aspalto?
Sa dalan mo.
Dalan, yeah. We use asphalt sa roads. And that is the reason why if naka-aspalto ang daan class, ang road, slippery, no? Slippery siya. Kasi nga galing siya dito sa crude oil. But nevertheless, the process is called fractional distillation. That's the process they do in order for them to separate the different na mga oils natin from the crude oil. So we have the gasoline, kerosene, the diesel, and lastly, the asphalt. Okay? Sa perfume din. Sa pharmacy, you have the subject called pharmacognosy, and yan yung subject wherein you will be taught how to make perfume. Okay? So you will be making perfumes also. So when I was a student, also sa pharmacy, pero syempre sa Davao kung nag-eskwela, naghimo jud mi og perfume. Akong problema, di man ko humot ng perfume, may baho man tug. baho man to kanang lard ng tambok bitaw sa baka or sa baboy. Kasi that's how you make perfume. You get petals from the flowers, ilalagay niyo siya sa lard or sa fats ng sample baka or baboy. And then after how many days, magdi-distillation process ka na. Ilalagay mo yung the whole lard dito and then maghihintay ka na mag-evaporate. Yung oil na galing sa petal, mag-evaporate yan siya and makukuha mo dito sa flask. Pero dapat kasi efficient yung distillation process na you will get rid of the amoy ng lard or yung oil na ginamit mo dito. So sa amin kasi parang natalo yung amoy ng petal. Waling-waling among gamit ato nga na flower. Natalo kasi yung amoy niya sa amoy ng lard. So wala akong ganahan sa product sa perfume. So mahal ang perfume class ha, kay makalbo na ang inyong plant class, ang inyong nakuha nga oil, wa pa kaabot 1 ml. So again, that is the reason na masyadong expensive yung mga totoo talaga na perfume ha, na like oil-based perfume. Konting-konti talaga yung makukuha natin sa ating petals. Okay? So, evaporation is still an process of separating mixture na define na natin yan kanina. Magnetic separation, we always do this as a kid. Like if we have magnet, we played with magnet. Like sa sand, di ba? Sineseparate natin using our magnet. And then in the laboratory, we always do filtration process using filter paper. But that is not limited to filter paper only. We can also use cheesecloth or asbestos or wool as a filtering medium if we want to separate, for example, a liquid from a solid. And then we have sorting. That's the mechanical separation, as in mano-mano na pag-separate sa mixture. Again, that is called sorting. Even pag maglaba ka, nag-sort ka, di ba? Hinahiwalay nimo ang puti sa decolor. Okay? And then we have the centrifugation. Are you familiar with centrifuge? Sino dito ang familiar with the centrifuge? Okay, so have you seen the centrifuge?
Yes, ma'am.
Okay. So for those who are not familiar with the centrifuge, marami tayong ganito sa laboratory. We have here the centrifuge. So ganito yung mukha ng centrifuge. And as you can see inside class, we have the test tubes. So yung mixture, nilalagay siya sa test tube and pinapaikot inside. So ang kanyang process is like using the washing machine. Pero pinapaikot inside. And because of that centrifugal force, the particles that we want to separate will actually settle at the bottom. Okay? The centrifugal force helps the gravity to pull down the particles at the bottom. And then pag nasa baba na siya, then we can do decantation process. Yung liquid above can be thrown away. Pwede natin siya iyabu. And then na separate na natin. We use centrifuge in many laboratory procedures, but most of the time, we see the centrifuge sa school, sa medtech lab. Kasi yung mga medtech mostly ang gumagamit nito, especially if they want to separate the serum from the whole blood. So pag nag-extract sila ng dugo, nilalagay nila sa test tube and pinapaikot nila dyan sa centrifuge. That's how they separate the serum again from the whole blood. I hope that is clear. You have questions? Urine din, yeah. Sinasubject din nila yan sa centrifuge ang urine if they want to let the particles in the urine settle down. Okay, mag-settle down yung mga particles na nasa urine. So that is still a process of separating mixtures. Okay? Now, we also have the so-called fractional crystallization. Pag crystallization class, from liquid, magiging solid siya. Meaning, gagawin natin siyang crystal. Okay? Pero yung, paano natin ma-separate ito? Yung unang mag-crystallize class, yun yung unang ma-separate. Okay? Kasi hindi yan sila. Kung meron kang mixture na, example, liquid sila lahat, maraming nandoon, maraming component ang mixture mo pero liquid sila lahat. For example, pag sinubject natin sila at very low temperature, hindi yan sila sabay-sabay magsusolidify. So the one that solidifies first or nag-crystallize first, yun yung una nating masa-separate. Again, that's the process of fractional crystallization. We subject the mixture at a very low temperature. Okay, so meron tayong equipment for that na very low ang temperature. And lastly, we have the chromatography. So we also do this sa pharmacy, especially yung mga plant materials natin. Example, the drug discovery tayo using our plant materials. We will have the extraction process. Pag nakuha natin yung extract from the plant, if we want to separate the different plant components, meron tayong tinatawag na phytochemicals. So kung anong meron doon sa plant, pwede natin actually ma-separate using chromatography. Okay, pero nakadepende ito sa solvent affinity, meaning gagamit tayo ng solvent. Merong aqueous na solvent, so syempre water, and merong ang tawag dyan, lipophilic na solvent. So example, yung mga organic substances natin. So pag nilagay natin yung extract, kung ano yung matutunaw sa water, yun yung makukuha natin doon sa aqueous na phase. And kung ano yung matutunaw doon sa like mga organic solvents, yun din yung makukuha na plant component. Okay, anyway, maraming types of chromatography, but please know that chromatography is one process of separating mixtures. Okay, questions before we'll summarize this and move on to another lesson? So again, pag matter ha, can it be separated by a physical process? Pag hindi, automatic, that is a pure substance. Now, sa pure substance class, kapag ka ma-break down siya using chemical process, mahiwalay natin siya using a chemical process, that's what you call compound. Pag hindi, syempre, the simple substance which is called the elements. Yung mahihiwalay using physical process na bago lang natin diniscuss, automatic mixture yon. Pag uniform, that is homogeneous. Pag hindi, that is heterogeneous. Okay? Sige, questions or clarifications? Wala. Sure. Sure na yun. Kaya pa? Kaya pa mamahaw jud pag chemistry karon. Basta Thursday, inyong pamahaw chemistry. No, sa iyo petong klase 7:30. Okay lang na kay it's at tay parehas ta walay ligo din. Naka-record nga wala tay ligo. Okay, we have the measurable properties of matter. So, mga properties, ito ha, na mini-measure natin. We have two types of measurable properties, the extensive property and the intensive property. How do I memorize this one? Paano ko ito ma-remember and paano ko siya ma-differentiate? In for independent. Ganito ko siya pinag-aaralan. In for independent. Independent saan? Sa amount of matter. Okay? So meaning when you say intensive, it does not depend on how much matter is being considered. Therefore, automatic si extensive depends on how much matter is being considered. Let us give an example. Pag sinabing extensive, volume, the more na maraming matter or maraming material na present dyan sa sample mo, the more tataas ang volume. Tama? So yan yung dependent siya sa how much matter is being considered. That is also true for mass. Pag daghan kaayo ang imuhang substance, syempre mo taas ang mass. Kung gamay lang, syempre magbaba. So the mass now depends on how much matter is being considered. That is why it is included here sa extensive property. You know also sa size. Syempre, pag daghan imong substance, mudako ang size. That is also true for weight and for length. So all of them na gina-measure nato class na dependent sa unsa kadaghan imong matter is called extensive property. Okay? Now how about the intensive property? Sabi ko kanina, independent from the amount of matter being considered. Example, boiling point. What is the boiling point of water? What is the boiling point of water?
100 degrees Celsius po, ma'am.
Okay, very good. 100 degrees Celsius. Pag nag-boil ka og isa ka baso na tubig, kanus siya mag-boil? Pag ma-reach na niya ang 1 glass, 1 glass of water. What's the boiling point of 1 glass of water? 100 gyapon, no? Tama, 100 degrees Celsius. Paano kung nag-boil ka og isa ka drum na tubig? What's the boiling point? That is still 100 degrees Celsius. So ito yung sinasabi ko, class, na independent on how much matter is being considered. Hindi nagbabago ang kanyang property or yung kanyang measurement kahit na nagbago yung amount. So kagaya ng boiling point, isang baso lang yung binoil mo, 100 degrees Celsius pa rin yan. Pag isang drum, dumami yung water, pero 100 degrees Celsius pa rin siya mag-boil. We call that intensive property. Okay, so same lang. Even the color, same lang. Wala nagabago. Nang kay isa ka basong orange juice o isa ka drum na orange juice, orange gihapon iyahang color. Wala siya naga-change. So the color is under intensive property. The temperature also does not change. Pag measure nimo sa temperature, example, gibutang nimo sila sa ref. Isa ka basong tubig o isa ka pitsil na tubig. If you measure the temperature, wala na siya naga-change even if daghan ang imuhang amount sa water. Unless na lang kung ang imuhang gidugang kay lahi po ng iyang temperature, no? Pero kung the same ang ilahang environment, ang amount lang ang dili, the same, they have the same temperature. The luster also, especially for our metals, daghan man imong gold or gamay lang imuhang gold, that is still the same luster and even the hardness. So aside from that, we also have the density and the specific gravity. Please include them here. What is the density of water? By the way, how do you define density? Density is what's ang density? Yes, Mr. Alcala.
Ratio of mass to volume po.
Okay. M over V. Okay? Mass over volume. That's density. Now, what is the density of water? Yes, Atasha.
977 kilogram po.
Ang density. Ano ito?
997 po. Ang density.
997. That's water, ha? Pag
Yes
water,
po.
ganito, ha? Water class, our density is just 1 gram per ml. Ang ibig sabihin ng density, ang isang ml daw na tubig, pag i-weigh mo yan, 1 gram siya. That's the meaning of density. Again, so if ang water, ang kanyang density is 1 gram per ml, ang isang ml, mag-weigh yan siya ng 1 gram. Or if meron kang 1 gram na tubig, ang volume niya ay 1 ml. That's the meaning again of density. So si density is an intensive property. Kasi kung meron kang isang basong tubig, ang density niyan 1 gram per ml pa rin. Pag isang drum ng tubig, ang density niyan 1 gram per ml pa rin. So hindi siya nagbabago. Na ang weight ng isang ml na tubig ay still 1 gram. Okay, so I hope that is clear. Okay, the specific gravity also is included there. The specific gravity is actually the density of the substance, the ratio of the density of the substance and the density of a reference standard. Most of the time it's water. Okay? So yan yung specific gravity. Hindi yan siya nagbabago din, class. Kagaya ng water. Ang specific gravity ng water ay 1. Kung meron kang isang basong tubig, 1 ang specific gravity niyan. Pag isang drum, 1 pa rin. Kasi remember, density of the substance, it's water, 1 gram per ml. Density of a reference standard, which is still water, that is still 1 gram per ml. So, si specific gravity niya ay still 1. So, hindi siya nagmamatter kung gaano karami ang tubig mo, magsistay yan siya as 1. Okay? So, I hope it's clear sa inyo, class, na pag tinawag siyang extensive property, dependent siya sa kung gaano karami ang ang substance mo. Ang intensive property, hindi yun nagmamatter. As is, the same pa rin yung property na yon kahit pa dumadami ang substance mo. Okay? Questions? Wala? Sure? Nagyun? So let's summarize this one. Properties of matter. We have the diagram here. Can the property be determined without changing the identity of the substance? We're talking about physical and chemical properties here. Pag no, hindi mo siya madedetermine kung walang chemical reaction. Siyempre, chemical properties yon. Example, reactivity. How will you know na nagre-react ang substance kung hindi ka mag-undergo ng chemical reaction? Pag chemical reaction, there will be a change in the identity of the substance. Flammability also. How will you know na it's flammable if hindi mo siya susunugin? And if susunugin mo siya, di ba mag-change ang kanyang identity? Galing sa substance mo, example, magiging abo siya. Okay? So kapag ang properties na yun again, ay hindi mo madedetermine without a chemical reaction, without changing the substance itself, the identity of the substance, it's chemical property. Pero pag yes, madedetermine mo yung kanyang properties kahit na walang change sa substance na nangyari, physical property ang tawag dyan. And under sa physical properties, ito yung extensive and intensive properties. Nasabi ko kanina, extensive is dependent kung gaano karami ang substance mo, like the mass. The more na maraming substance, syempre tataas ang mass. Pero yung intensive properties, hindi nagmamatter ang gaano karami yung amount ng substance mo sa property na ito. Kagaya ng odor. Example, may panis ka na kanin. Sa isang kutsara na panis na kanin and isang kaldero na panis na kanin, hindi naman nagbabago ang odor. Ganun pa rin naman ang odor ng panis na kanin. So, kasali siya dyan sa intensive properties. Okay? Sige, I hope that is clear. Questions or clarifications so far? Wala? Take 2. Okay. Again, let's have the changes that matter undergoes. The first one is physical change. Pag sinabing physical change, class, there is only phase change. What do I mean by that? Like, when you say phase change, we just have the change like solid to liquid, liquid to gas, and vice versa. So, example, we have here solid to liquid, liquid to gas. And yung examples ng physical change. What do you call the process of turning solid into liquid? Ang tawag sa process pag ang
Solving, ma'am?
Saan sa?
Solving po ba, ma'am?
Solid to liquid. We call that
Melting.
Melting.
Rough what you said. Medyo choppy. That is
Liquefaction. Ay, dili din.
Yeah, melting. Okay? Melting, or we call this fusion. Okay? Sometimes we call that fusion. But anyway, that is commonly known as melting. Pag ang solid naging liquid. Paano kung ang liquid gawin nating gas? Ang tawag dyan?
Boiling.
Okay, evaporation. Again, that is called evaporation. Pag ang liquid gawin nating gas. Paano yung baliktad? Ang gas gawin nating liquid. Sabi natin to kanina.
Condensation, ma'am.
Very good.
Condensation, ma'am.
Very good. This
Condensation.
condensation. Paano ito? Baliktad. Liquid to solid.
Solidification.
Freezing, ma'am. Ay.
Freezing.
Ay, tama. Mali. Ay,
Solidification. That is also correct. Okay? So, freezing. Liquid to solid, that is freezing. Paano kung solid diretso sa gas without, undergoing the liquid phase anymore? Yes. Artea.
Ay, ano ulit tong question, ma'am? From solid
gas.
to gas po. Ano, ma'am? Nakalimutan.
Deportation po.
Ay, sino yun? Sorry?
Sublimation.
sublimation.
Okay, very good. Sublimation. Kagaya ng nangyari sa naphthalene balls. You know naphthalene balls, right? Mothballs. Yung ginabutang nila sa cabinet.
Para sa ok-ok, ma'am.
Para sa ok-ok. Very good. That actually undergoes sublimation. Why? From solid, di ba? Mothballs are solid. And then automatic magiging gas yan siya. So even though you cannot see the solid material anymore, you can still smell the odor of the mothballs, the naphthalene balls. So that's his sublimation. Paano yung baliktad niya? Siyempre may baliktad yun. It's going around. Yes. Anyone? Anong kabaliktaran nito? Solid to gas, sublimation.
Deposition, ma'am.
Deposition.
Okay, very good. The process of turning gas into solid is called deposition. Okay, deposition yan siya. So ito lahat, class, ito lahat na processes are just physical change. Okay, there is a change, but it's just a physical change. When you say physical change, there is only phase change. There is no new product that is formed. Therefore, ganun pa rin. Kung tubig naging ice, tubig pa rin yun. Okay? Kung nag-evaporate siya, naging water vapor, that is still water. So again, there is no new product that is formed. We only have phase change, and you can turn it back to its original appearance. Okay? So yan yung tinatawag na physical change. So kagaya ng butter, if the butter melts, that is just a physical change kasi it is still butter. Nag-melt lang siya. Okay? From solid, naging liquid siya. Yeah, that's physical change. Now, how about the chemical change? The chemical change happens when there is a change in both the intrinsic and extrinsic properties of the matter. So remember kanina, dinefine natin si intrinsic and si extrinsic. Si extrinsic yung nakadepende sa amount ng substance. Si intrinsic yung independent from the amount of the substance. If merong changes sa mga properties na yon, automatic, that is a chemical change. Sabi ko kanina, ang boiling point ng water ay 100 degrees Celsius. Pag nagbago yan, hindi na 100 degrees Celsius, then it's no longer water. So merong bagong product na na-form. Therefore, chemical change yun siya. Okay? So again, anong tandaan natin for chemical change? There is new product that is formed and you cannot, most of the time, turn it back to its original form class. Okay? So kagaya ng sinunog mo ang papel, naging ash siya. So the ash there is a new product. And you cannot turn it back to the original appearance na papel siya. So again, chemical change ang tawag dyan. Nahulog na naman. Okay? So ito yung mga evidences na there is really a chemical change that take place. So we have here evolution of gas. Pag merong na-form na bubbles, merong gas na nag-evolve, that is a chemical change. So what's an example of that? Effervescent preparations or effervescent tablets. Sino na yung nakatry na gamot na nilalagay sa tubig? Tapos nag-bubbles siya. Tawag natin dyan, effervescent preparation. Anong gamot yung ininom ninyo? Anong gamot yun? Nilagay niyo sa tubig? Nag-bubbles.
Para ata sa ano ma'am, sa ubo ba to ma'am? Kalimot ko bata.
Yeah, the fluimucil.
Atong acetylcysteine, ma'am. Tong tablet form niya.
Oh yeah, the acetylcysteine. Ang brand name atong common na brand name sa market kay fluimucil. 'Di ba may tablet yan siya na masyadong malaki, hindi yan siya iniinom. As madunlan kun tanod ako kayo yung tablet. Ilagay natin siya sa water and as we place that in the water, there is evolution of gas. Therefore, may chemical change na nangyari doon. Yeah, meron tayong vitamin C. May vitamin C tayo na nilalagay din sa water and mag-release siya ng gas. Yung Beroka, that's still an example. The hydride, kapag ka nag-diarrhea kayo, the hydride is also, is there a chemical reaction sa hydride? I'm not familiar. But anyway, pag nag-evolve ang gas dyan, there is evolution of gas, then that is a chemical change. Formation of a precipitate. Take note, class, when you say precipitate, that is an insoluble substance formed during the reaction. So example, meron kang liquid na substance, tapos hinalo mo siya sa another liquid na substance. Nung hinalo mo na sila, ang nangyari, meron kang liquid na substance pero may nabuo na solid na hindi na-dissolve. So ang tawag dyan sa nabuo na solid na hindi na-dissolve is a precipitate. Okay? Precipitate ang tawag dyan. So, pag merong ganito, that is an evidence na may chemical reaction or chemical change na nangyari. Questions? Wala? Sige, emission of light is also evidence of chemical change. Generation of electricity is also a chemical change. Production of mechanical energy, kapag may mga light energy and mechanical energy involved, there is a chemical change. And absorption and liberation of heat. We have a lot of experiments in the laboratory wherein if we are going to mix one chemical to another chemical, there is liberation of heat. Iinit, magiging mainit, though hindi mainit originally yung substance, pero pag pinaghalo mo sila, magiging mainit yung temperature. So that is again an evidence of a chemical change. So pag nagpariband ka o buhok, is that a physical or a chemical change? Once again, yung under sa akin parang tinanong ko to last time. Again, pag nagpariband ka ng buhok, physical or chemical change? What do you think?
Physical,
Physical,
ma'am.
ma'am.
Physical, ma'am.
Pag nagpariban ka buhok,
Mental po.
sige, isipon doon
Mental,
nato.
ma'am.
Pariban ko buhok, number 1, buhok gihapon siya. Wala siya nahimong lain nga bagay, no? Number 2, sinahitabo sa buhok? Straight. Okay, sige. Number 3, mabalik mo pa ba siya sa original niya na form?
No na po.
No. Yeah, very good. So kung hindi mo na siya nabalik sa original niya na form,
Chemical dye, ma'am.
Chemical change.
okay, very good. When you have your hair rebonded, that is, class, an example of a chemical change. Okay? Chemical change yan siya. Yung una kasi, buhok pa rin kasi siya. Oo, tama yun siya. Na straight lang, na bago yung form. Pero dili naman siya magbalik sa dating form niya. Magkulot ang buhok mo ulit kapag tumubo na siya. But the part class na ni-rebond, hindi na yun siya babalik. That is a chemical change. Because of the chemicals na nilagay sa buhok class, there is breakage of protein bands sa buhok, kaya siya naging straight. Okay? And then again, since broken na yon, hindi mo na siya mababalik, hindi mo na siya madudugtong, kaya hindi na siya kukulot ulit. Except, again, kapag tumubo na ang iyong buhok. So, chemical change yun siya. So, how about the boiled egg? Physical or chemical?
Chemical, ma'am.
Chemical. Pag nag-ano ka, so tawag na, nag-boil ko egg, the boiled egg mismo. Itlog na gihapon. Itlog gihapon siya, no?
Chemical change.
Chemical, ang uban physical. Ano physical man? Kaya itlog gihapon siya. Pero ang isipin niyo, class, kung mababalik mo pa ba siya sa original niya na form. Kung nag-boil ka ba ng egg, mababalik mo pa ba siya doon sa kanyang original na form?
Hindi, ma'am.
Hindi na.
Okay.
Hindi na. Pag hindi mo na siya mabalik sa original form niya, that is automatically chemical change. Chemical guro, dili mo sure. Again, ang itlog class, pag gilungag na nimo, gipaboil na nimo, dili na gyud na siya mabalik sa original na form. Magic ang tawag ana pag nabalik siya sa katong liquid pa siya. Okay? Paspas ni Balhin of chemical. So you have to take note of that, ha. Even if sa first nimo na check, it's still egg. Pero if you look at it deeper, if you cannot turn it back to its original form, automatic, that is chemical change. Murag ka mo sa iyong ex-mom, chemical, di na mabalik. Kapag there is second chance, that's physical change. Kung balikan mo siya, physical change na. Pero if you stand by your decision, walay balikanay, sa mukay, pag walay balikay, that's a chemical change. Okay, pag ang band glass na putol, pag ang band na break, and pag mabalik pa nimo ang band, that's physical change. Pero pag hindi na, that's chemical. So I hope hindi niyo yan siya makalimutan and walang ma-confuse between physical and chemical change. Okay? So another question. Yeah, kahit walang chemical na ginamit, as long as class, hindi mo siya mabalik sa kanyang original form, may new substance na na-form, automatic, that's chemical change, ha? Sige, another question. Pag namalansya ka, you iron your clothes. Physical, chemical.
Physical.
Physical po, ma'am.
That's an
Physical,
example of a clear physical change. Ano naman, number 1, sinina maghihapon to siya. Number 2, na straight lang man siya and then pwede mo siya makumot ulit, diba? So that is physical change. Okay? How about if the iron rusts? Yung iron nagtaya. Physical, chemical.
Physical, ma'am.
Chemical.
Pwede mo man siya lagyan ng
Chemical,
sopa.
Chemical, ma'am.
Chemical.
Nakatulad ko sa chemical.
Chemical.
Yeah, that is a chemical change yung sa nalagyan ng acid yung skin, yung mukha, chemical change yun. Pero ano yung question ko? Iron rust. Chemical, ma'am, anak kong sa 5 minutes life hack. So, saan siya? Well, that's a video. Anyway, class, that is a chemical change. It's the iron rust. Ang nangyari kasi dyan, bakit siya nag-rust? Yung iron, nagkaroon ng reaction with oxygen. So, ngayon, magre-react yan silang dalawa, nagtaya. Now, you cannot turn it back to its original form. Hindi mo mababalik si iron. Pero may nagsabi kanina, gamitan mo daw siya ng suka. Remember, if you use suka, suka is a chemical substance. Therefore, that's another chemical reaction there for you to remove the rust. Okay? So, when iron rust, that is a chemical change. Paano, class, if the leaves wither? Physical or chemical? Pag nalaya, ang
Chemical.
dahon,
Chemical, ma'am.
Chemical,
dahon
ma'am.
na gihapon. Pag nalaya ang dahon na gihapon, pero chemical change,
Hindi
ha?
naman siya mabalik, ma'am.
Yeah, it's magic kung mabalik siya o pagka-green. So, chemical change na siya. So, I hope wala nang ma-confuse, ha, between physical and chemical change. Okay? Questions or clarifications?
Wala po, ma'am.
Sige. So let's talk about chemical change. We have here processes involved in chemical change. Number one is oxidation. Oxidation happens when there is a interaction of the chemical to an oxygen. Okay? Kagaya nung nag-rust ang iron kanina. Diba? Pag meron kang iron na metal dyan, tapos mag-react siya with oxygen, magkakaroon ng rust. Magtataya yung metal ninyo. Yan yung example ng oxidation. Ano gani inyong apple? Di ba pag panitan ninyo inyong apple, what happened? Yung sa apple, pag dili ninyo
Mag-brown, ma'am.
Brown.
Pag itom-itom, ma'am. Ay, brown.
Mag-brown.
mag-brown. Mag-brown ang apple. That is actually the interaction of the tissues ng apple sa oxygen. So, ang tawag pa rin dyan ay oxidation. So, when you hear the word oxidation next time, please know that it is because of the oxygen. So, there is gain of oxygen and sometimes there is loss of hydrogen. So, depende lang. Kung nag-gain siya ng oxygen, oxidation yon. Kung nag-lose siya ng hydrogen, oxidation pa rin ang tawag dyan. And if we are going to check their oxidation state, magkakaroon ng increase in their oxidation state. Okay? So how do we know that na nag-increase ang oxidation state? What time is it? 10 minutes na lang. Let me make this quick. You have your periodic table there. Do you have it? Can you take out your periodic table? Kasi ako wala akong periodic table dito. So magdodraw tayo ng periodic table. Your periodic table looks like this, right? Tama?
Yes,
Okay.
ma'am.
So we have hydrogen, helium, lithium, sodium, potassium, rubidium, cesium, and francium. And then we have here beryllium, magnesium, calcium, strontium. Anong wala na nagpantay. Dako kayo akong gisulat. Wait lang. Anyway, kahit wala nagpantay ha, kaya diligyan ako ni mas straight din kaya nagsulat ra ko. Erase na siya tanan. Na-erase lang. Okay, sige na lang. Ay, na-erase na tanan. So we have beryllium, magnesium, calcium, strontium, barium, and radium. This is how your periodic table looks like. And then dito sa kabila, ay, Ano naman na siya? We have boron, carbon, nitrogen, oxygen, fluorine, helium sa taas. And then we have here the so-called transition metals. Class, do you know how to identify the charges of the elements? Example, pangutanon ta mo, sodium. What is the charge of sodium? Hindi niyo alam. Sino may alam dito sa charge ng sodium? Wala? Sige, let's not make our lives miserable. Let's let's make our lives easier. You look at your periodic table. All elements in the group 1A ang charge ana positive 1. Para dili ta maglisod sa atong life. Again, let's look at the by group ito ha, vertical na groupings. Halina kay Ruby, cesium, francium. That's how I memorized the first column in the periodic table. Halina kay Ruby, cesium, francium. Lahat sila positive 1. Magka-serbara. That's the elements found in group 2A. Lahat sila positive 2. Nakuha? And then, boron, pababa. Boron, aluminum, pababa. Lahat sila positive 3. Okay? Carbon, pababa. Pababa ha, carbon pababa. Can be positive 4, pwede din negative 4. So, carbon is the reason why we break down chemistry into organic chemistry and inorganic chemistry. Your subject now is called inorganic. Atong subject na to karon, pharmaceutical inorganic chemistry. Sa inyong second year, you have organic chemistry. So ngayon, sa subject natin, we will concentrate to all the elements except carbon. Okay? So again, kasi carbon is the reason why we have inorganic and organic chemistry. Kasi carbon behaves differently with the other elements. And then pagdating natin kay nitrogen class, di na ako may straight akong ginasulat. Lahat ng elements nitrogen pababa, negative 3 yan sila. And then pagdating kay oxygen, we call them chalcogens, negative 2. Okay? So sulfur ang nasa baba ni oxygen, right? So oxygen pababa, negative 2. Now itong fluorine, pababa, fluorine, chlorine, bromine, iodine, and astatine, lahat sila negative 1. Okay, para madali ang ato ang life. Dili mo magsigig hunahon may charge atong element. Be familiar with the elements in the periodic table, ha, their names and their symbols. Yan yung assignment ninyo. Again, be familiar with the names of the elements and their symbols. Okay? So negative 1 pababa. How about si helium? Helium, argon, xenon, krypton, wala silang charge. Okay? Kaya, anong tawag sa kanila?
Noble gas.
Okay, noble gases. They are called noble gases because they don't really react with other elements to form a compound. They can stand with themselves alone. So, itong tawag sa ilaha, strong, independent elements. Kaya, tinawag silang noble gas. Okay? And then to end, yung mga elements na nasa gitna, mag-skip ako sa sa center, they are called transition metals. Most of them are positive 2 with few exceptions. So next week, yan yung ituturo ko sa inyo, ang exceptions sa transition metals. For the meantime, since already almost 9:30, dyan muna mag-e-end yung discussion ko. We will continue with oxidation. Next meeting, I will teach you class how to identify the oxidation state. Assignment. Assignment ninyo. Nasabi ko na kanina yung assignment ko sa inyo. Be familiar with the names of the elements in the periodic table, their symbol, and at the same time their arrangement. Just like when I say, where can we find sodium in the periodic table? Kailangan masagot niyo ako na si sodium ay nasa group 1. Group class yung horizontal, vertical na grouping sa periodic table. Okay? So yun yung assignment ninyo. Hindi yun written. Kailangan nyo siyang studyhan para mabilis tayo class sa chemistry. So welcome to pharmacy. Magsugod na yun ang pharmacy life. Ha? Pag pharmacist ka class, kaila jud ka sa tanang elements. You know all the symbols and you even know where can we find that element in the periodic table. Okay? So that's it.